Let's look now at the properties of some different types of triangle. So the first one we've got here on the left, equilateral triangle, and that's just a triangle where all three of the sides are the same length, and also all three of the angles are going to be the exact same size. They're all going to be 60 degrees because the angles in a triangle add up to 180, so if they're going to be the same, they're going to have to be 60 degrees. The next one is an isosceles triangle. That's ISOSCELES triangle. And that's one where there's two sides that are the same length, but the other side is a different length. And what this also means is we've got the two angles that are opposite those sides that are the same length are also, they're going to be the same size, but this third angle, the one that's between the two sides that are the same length, that's going to be a different angle. And the third type we've got is a scalene triangle, and that's one where all three of the sides are different lengths, but also all three of the angles are different lengths. So next I'm going to look into a wee bit about finding the perimeter of these. So if we've got an example where we're told that this side is 2.5 centimetres, and we're asked to find the perimeter. Remember, the perimeter of a 2D shape is the length just right round from one point, going right round outside till we get back to it. So because it's an equilateral triangle, right away we can say, well, this must be 2.5 centimetres as well, and this must be 2.5 centimetres. So our perimeter is just going to be 2.5 plus another 2.5 plus another 2.5, and that's going to give us 7.5 centimetres. Just going to be centimetres because it's not an area, it's just a length. Now the next one, we could be told that this was 4.5 centimetres and this was 3 centimetres. If we're asked to find the perimeter of this, now we've only been given two sides, but right away we can say this is isosceles, so these two are the same length, so I can say that's 4.5 centimetres as well, and our total perimeter is just going to be 4.5 plus 4.5 plus 3, and that's going to give us 12 centimetres. Now I'm going to approach this one a wee bit of a different way. If we're told in this one this length is 3 centimetres and this length is 5 centimetres, and we're also told that the perimeter of this triangle is equal to 14 centimetres, and we're then asked how can we find out the length of this side. Well, if we call the length of this side, say L, we can say 3 plus 5 plus L equals 14. So L is the number that we add on to 3 and 5 to get up to 14. Another way we could say it is 14 minus 5 and also minus the 3 is going to give us that length there. So that length is going to be equal to 14 minus 5 minus 3, that's just going to be 6 centimetres. And just to check, 6 plus 5 plus 3 does give us the perimeter of 14. Now I'm going to look over the page at a few different ways of naming triangles rather. So the first one is an acute angle triangle, and that's where all three angles in the triangle are all less than 90 degrees. That is, they're acute angles. Now, a good example of this is an equilateral triangle because they're all 60, but you could get one where, for example, they were 60, 65 and 55. It would still add up to 180, but they would all be acute angles. The next type of triangle we've got is a right angle triangle. That's one where we've got one angle marked on as a right angle, as 90 degrees. We just mark that with the wee square, and the other two are going to be just acute angles. Now, you could get a right angle triangle that's also an isosceles triangle if these two lengths were the same. In this case it's not, in this case it's a scalene triangle, but just remember that sometimes it will be right angled and isosceles. And the next one is an obtuse angle triangle, and that's when we've got one obtuse angle and another two angles which are acute angles. Now you might think I've not covered a situation where you've got two obtuse angles or two right angle triangles where two of the angles are 90 degrees or more. But if we try and draw a triangle like that, say for example we draw a line there and we make this angle here a wee bit more than 90 degrees, and then we go to the other side of that and we say we'll make this 90 degrees or more than 90 degrees to make it obtuse as well. When we try and make a triangle with two obtuse angles, what we see is the two lines are never going to meet and it's not going to become a triangle. And we also know that the three angles in a triangle add up to 180, so if two of them are 90 or more, we'd already be over the 180, so that's not going to work.